Hi there. Let's take a look at the different forms that quadratic functions can take. First off, we have standard form, which is y equals ax squared plus bx plus c. This form tells us the y-intercept of the function and is the best form for performing operations. Now, why does it tell us the y-intercept? The y-intercept would be the point where the function crosses the y-axis. So wherever that point happens to be, we know that the x-coordinate of that point is 0. If you come up to this form and you plug in x is equal to 0, you will see that the a term or the quadratic term will drop out, as will the linear term. A times 0 squared plus b times 0 is all 0, leaving you with y is equal to c. So the y-intercept would be the c value. Second form that we usually cover is something called vertex form, and that is y equals a times x minus h all squared plus c. That form tells us the transformations and the vertex. So if you have studied this form, you know that the h value tells you the left and right translations, and the k value tells you the up and down translations. And if you apply those translations to the vertex, it will give you the new coordinates of the vertex from the parent function. And lastly, we have something called factored form, and that is y equals a times x minus p times x minus q. That form tells us the x-intercepts as well as the solutions to the corresponding equation. Now let's take a closer look at that. If you look at your x-intercepts, wherever they happen to be, the y-coordinate of the x-intercepts is always 0. So doing the same thing we did in the first one, if I plug in y is equal to 0, then I can apply the zero product property to say one of these factors has to equal 0. It could be the a, the x minus p, or the x minus q. Now, a can't be equal to 0 because if it was, everything would just drop out. So it must be one of the other two. Therefore, adding p to both sides, we get x is equal to p, and doing the same thing with the q, we get x is equal to q. So my x-intercepts will be p0 and q0, whatever those points happen to be. So there's our summary of the 3 different forms of quadratics and the advantages and information that we get from each one. Please check out my video on equivalent forms for a more in-depth review. I'll link that below.